Okay, so section 2.2c, we're going to be solving absolute value inequalities. And I kind of mentioned this before the recording started. We are combining two different lessons together. Okay, one of the lessons that we're going to combine is section 2.1c, which, let me just go to a easier looking problem. Look at example number 3 here. We were supposed to solve the absolute value of 10n plus 8 equal to 62. And the way you're supposed to do it is you break it up into two separate equations, right? And one of the equations would look very normal. It would be 10n plus 8 equals to 62. So right here, 10n plus 8 equals 62 on the left side. But then on the right side, there was a minor change, right? We still wrote 10n plus 8 equals to 62, but we made it negative. Okay, that was the only thing we had to do. Notice the absolute value symbols disappear when we break it up into two parts. Okay, so all you had to do, and I'll show you another example here. This is one with 0, but notice we just wrote v minus 2 equals 0, v minus 2 equals negative 0, and then we just solve both. Okay, so solving absolute value equations requires you to break it up into two different equations, but one of them you have to change the symbol on the right side, the minus sign, make it a negative. Okay, you're going to make it a negative. And then we're going to get this idea and we're going to put it together with section 2.2a. Okay, section 2.2a is just solving these things, solving inequalities. And the only thing you have to remember was that whenever you solve inequalities, if you multiply or divide by a negative number on both sides, you have to switch the inequality. So you can see right here in example 1, it said greater than or equal to. It became a less than or equal to because I divided both sides by a negative 3, right? But other than that, you basically solve these problems the way you would anything else, right? Just solve for a variable, and they want us to sketch it after that, okay? Well, we're going to combine those two ideas. There's one new thing I got to talk to you guys about, and that's the way the arrow points in the very beginning of the problem. And then from there, we can do some examples, okay? So let me go back to section 2.2c. All right, so again, we're combining two lessons that we've already done. We're going to put them together. So you should kind of feel hopefully comfortable doing this, but there is one thing that I need you guys to know before we get into it. So if you see the absolute value of, I'm just going to do x. I'm not going to put like x minus 5 or just an absolute value. And you see a less than or equal to, okay, one or the other. A less than or equal to some number. So if you see a less than or equal to, in other words, I always tell my students, if the arrows are pointing at the inequality, once you've solved for the inequality, the absolute value. If the arrows are pointing towards the absolute value, okay, so if this is the case, then this is an AND problem. So if the inequalities are pointing at the absolute value, then we say it's an AND problem. If they're pointing away, it's an OR problem. Okay? So here's the other part. If you see the absolute value of x, but these things are pointing in the other direction, then this is an OR problem. So notice we're actually combining three different lessons here, right? Section 2.2a, I think it was, the absolute value, solving for absolute values. We're also combining solving inequalities, and then with the AND and the OR addition, we're talking about compound, right? The stuff we just did, 2.2b. So we're getting a bunch of different things and we're saying, okay, let's put these things together. We know how to do each one individually. Let's do them all at the same time. Okay? So that's going to be our process for today. Okay? Solve for your absolute value. Pay attention to the arrow. That'll tell you whether your graph should be pointing away from each other or towards each other. Okay? So here we go. Like I said, you guys only have 8 problems. So let's see. We're going to solve and graph. So as usual, I always like to start with something on the easier side and then start moving a little bit more difficult. So we'll start off with this one right here. Number 1. The absolute value of b over 10 is less than or equal to 2. So we're just going to solve that one. Now remember what I told you guys. When we're solving for absolute values, you have to break it up into 2 parts. But first, make sure the absolute value is all by itself. Ours is, it says absolute value of b over 10. So it's all by itself. I don't have to move anything around. It's just the absolute value right there on the left side. Once it's set up, which this one's naturally set up already, break it up into 2 parts. Okay? Break it up into 2 parts. So the first one is going to look normal. B over 10 less than or equal to 2. Okay? And the next one is going to look a little different. Okay? It's going to say B over 10. What do I do to the number on the right side? I make it negative. But here's the little catch, and I'm going to make sure that you guys see it in a different color. The symbol is going to switch. Why does it switch? Because I switched the sign on the right side to negative, so I got to switch the symbol. So you're switching both symbol and sign. Okay? You're actually supposed to do that with the equation ones, but when you have an equal sign and you flip it, it still equals, right? If you flip an equal sign, it still looks like an equal sign. So that's why we never did it before, because you didn't have to. Here you do. So not only are you going to change the number, let me actually put this in green here. Change the sign of the number, you're going to flip the symbol as well. And now we're just going to solve. So let's go ahead and solve. I'm going to multiply by 10. So I get b less than or equal to 20. Okay, so that's multiplying by 10. And then on the other side, I'm going to multiply that by 10. And I get b greater than or equal to negative 20. Now this is a pretty extreme length, right? From 20 to negative 20. So I'm not going to do a bunch of little tick marks on my graph. Remember, this is an AND problem, right? How did I know it was an AND problem? Well, this piece right here tells me it's AND, because it's pointing at the absolute value. Okay? So these things should be coming towards each other. So let me draw a graph here, or a little number line. I'm not going to make it too big. I'm gonna go by 20s, okay? Just to make it easier. 0, 20, 40, negative 20, negative 40. Okay? So I'm going by 20s. And now let me draw both graphs. Actually, let me move this down just a bit. Give me a second. I'm going to just drag it. Okay. So the first one says b is less than or equal to 20, right? b less than or equal to 20. So solid circle. Oops, let me change the color here. Solid circle at 20. And it's going left. The next one says b greater than or equal to negative 20. So I'm going to go to negative 20. Solid circle. Greater than or equal to goes right. Remember, this is an AND problem, which means I got to figure out what they have in common. So here's what they have in common. That piece right there. So let me draw the answer. A solid dot. and a solid dot, like that. And there's your connection. Okay? That's your solution right here. Okay? That's your answer. So notice, pretty much everything we just did right now at the very end looks like section 2.2b. Right? We just did that one, 2.2b. But the way that we worked through the process revisited 2.1a, 2.2a, 2.2b. So it's a lot of different pieces we're putting together, stuff that we already went over. Okay? So that would be my solution. People have asked me, like, do I have to do all three lines? Remember, you don't have to on your quiz. Some people just drew the single line with the answer. Some people drew all three. What I did notice is some people did this. They left it like that, and I was okay with it. Like, I didn't mark off points for it. At least I don't think I did. If I did, when you see your quiz, let me know, because I shouldn't have. Okay? Some people did that right there, and then over here they did this, which I think they meant the line is supposed to look like that blue one, right where that yellow stuff is. Right? Which I was like, okay, I get it. And they did it like for 3 or 4 problems. So I only did a -1 and I put an explanation like you didn't complete your graph, right? But I understood what they meant. I think what they meant to do was to say like, this is what it's supposed to look like, okay? But make sure you guys draw it. Don't just tell me like it's supposed to look like that. No, make it look like that. Draw it for me, okay? So you'll see it once I'm able to give you back your quiz. You guys can check. So just to review really quick, and then we'll go on. For question number 1, we got absolute value of b over 10 less than or equal to 2. I noticed that it's pointing, the absolute value is being pointed at by the inequality. So remember, that's an and problem, right? That's going to be an and problem. We broke it apart into 2 pieces. The first one was normal, b over 10 less than or equal to 2. The second one, we had to flip 2 things, the sign and the symbol, right? So it had to go to a greater than or equal to and then a -2. Then I solved both, which should be natural, right? That shouldn't be a hard thing to do. Once I solved both, I graphed them, and there we go. So again, this was an and problem. I expected them to go towards each other. Why? The absolute value was pointing at, the absolute value was being pointed at by the inequality. Okay, so the inequality is pointing at it, so it's an and. So I'm expecting a collision somewhere. So that being the case, let's do an or. Okay, so I'm going to try an or, but we're going to change it up a little bit. Actually, let me not put 2x here. I'm looking at your problems. I didn't see any of them with 2x's, so we're just going to do like x minus 3 greater than 5. So again, the first thing you want to do, make sure the absolute value is all by itself on one side, and this one is. It just says absolute value of x minus 3, so that's perfect. I am going to kind of highlight something really quick for us here. Notice it's pointing away from the absolute value, so that means this is an or problem. Okay, so I don't know if you want to write that down somewhere. Or that means the graph should be pointing away from each other. Okay, so since the absolute value is all by itself, I'm going to break it apart into 2 pieces. Okay, x minus 3 greater than 5. So remember, the first one looks very normal, just without the absolute values. And then the next one's going to be x minus 3. And then switch your inequality. So we're going to go less than, and then make it negative, and then rewrite the number that was there. So you're switching 2 things, the inequality and the sign for the number. Now solve both. Again, this next part should not be hard. This is algebra 1 stuff right here, right? So we're going to add 3 to both sides. So x is greater than 8. And we'll do the same on the other side. We'll add 3 to both sides. X is less than -2. So I'm done. So let me go ahead and make a graph for this thing. So we'll do a -4, -2, 0, 2, 4, 6, 8. So that should fit everything. All right, we'll go to the first one. X is greater than 8. So open circle at 8. Greater than means go right. The next one, x is less than -2. So open circle at -2, and I go left. And I'm done. That's it. Now the first 4 problems don't get any more difficult than the 2 I just did. Okay? This one is not a problem. The one I just did is not a problem on your homework, but there's one that says x plus 10 is greater than or equal to 1. So basically same thing. But it's just you don't have a lot of ors in the first 4. So I wanted to make sure I did one of the ors without taking away the only one you had. So are we okay so far with this? All right. Now I'm going to do one more. Like I said, I didn't want to do a whole bunch, but I want to do another one that's a little bit on the more difficult side here. So this is from your homework. So we're going with the hardest looking one on your homework. Now you should notice that the absolute value has the inequality pointing away from it. It doesn't necessarily mean that it's an OR problem yet. You only make your decision of and OR once you've isolated the absolute value. You got to make sure the absolute value is all by itself. So we got to move everything around, because sometimes when you move things around, you'll flip symbols because you're dividing by negatives and stuff. So we got to wait till the end before we can make a call whether this is an and or an or. Right now it looks like an or, but we'll see. Okay? So what's the first thing I have to do here? And don't say add 3 plus 7. I -3. I know a lot of times we want to add that, but remember 7 is multiplying, 3 is adding, so they're not next to each other to add. So we're going to subtract 3, right? Subtract 3. So I get 7, absolute value of 6 plus x is greater than 14. All right. What's my next step? 7 is multiplying the absolute value. How do I get rid of 7? Divide it, right? So we're going to divide it by 7. So absolute value of 6 plus x is greater than 2. Now, my absolute value is now isolated. The inequality is pointing away. So that means that because of this, this is an OR problem, which means my graph should be pointing away from each other. Okay? That's when I make the call. I don't want to do it in the very beginning. Okay, and you might say, well, if I would have done it in the very beginning, it would have not changed. That's true. But if this would have been a -7 right there, instead of a +7, I would have divided both sides by -7s. It would have flipped the symbol, and it would have become an and. Right? So it just depends the way it looks. So you got to work through it first before you make that call. Get your absolute value all by itself, and then figure out whether it's an and or an or. Okay? Now, is it the most important thing to know that it's an and or an or? Not really, but it's nice if you know, because when you graph it, if you see them going away from each other, and you know it's supposed to be an and, that means something's wrong. Right? Or if you know that it's an or problem, but they're going towards each other, then something might be wrong. Okay? So it just helps to check. So here we go. Let's break this up into 2 pieces. So first piece is 6 plus x greater than 2. The next piece, 6 plus x is less than -2. Yeah, you switch the symbol, you switch the sign, okay? You switch the inequality, you switch the sign of the number. All right, so solve for both. -6 on both sides here. We get x greater than -4. Okay, well, -6 on both sides over here. X is less than -8. Let's draw our graph. Remember, this is an OR problem, so I don't have to draw like a bunch of stages, right? This is going to go in opposite directions. It should go in opposite directions. So here we go. -4, -8. I'm just going to go by negative. So -2, -4, -6, -8, -10. And we're going to draw our two lines. X greater than -4. So at -4, an empty circle. And greater than means go to the right. The other one, x less than -8. I'm going to go to -8, empty circle, go to the left. And I'm done. And that's what you guys are doing for homework today.